This is the Minding Your Own Business podcast, brought to you by Elder Research. Each episode will bring in data and analytics gurus from around the world as they regale us with their data analytics stories and enlighten us with their secrets for how to turn data into actionable insights. Now, here's our host, Evan Wimpey, who will guide us as we dare to mind our own business.
Hello and welcome to the Minding Your Own Business podcast. I'm your host, Evan Wimpey. Today, very excited to introduce two guests for our first of hopefully many debate episodes. We've got Robert Robison and Aric LaBarr here to debate the resolution when building a model for classification purposes. AUC is the only metric that you need to consider. So I'll do a quick introduction and let these two smart folks jump to it. But Robert Robison is a senior data scientist at Elder Research, one of our best and brightest. He will be debating for the affirmative of the resolution. And then Dr. Aric LaBarr is a associate professor of analytics at NC State. Go Pack. Okay, that's my grad school. I don't actually say go Pack, but Aric was a teacher of mine there. And so also one of the best and brightest. And I will say, how can two smart people disagree on something like this? I will preface our audience with the hope of today's debate is not to have a winner and loser, is to inspire some thoughtful considerations and to show how non-personal this is. Both Robert and Aric were eager to debate either side of this resolution. So there are no hard feelings either way. This is just where we ended up, Robert with the affirmative and Aric with the negative. So, gentlemen, thank you so much for joining. We will start out, Robert, with you for 5 minutes arguing in the affirmative. Take it away, Robert.
All right. Thanks, Evan. Thanks for having me on to do this. Super excited about it. So I'm arguing for the affirmative. The AUC is the only metric you need to consider. So I'll start with defining what the AUC is. AUC is a measure of how good a classification model is. Higher AUC is better, lower AUC not as good. It's usually between 0.5 and 1. So 1 would be your model is perfect. 0.5 means your model is just randomly guessing. And that's true regardless of the problem, regardless of how many ones or zeros you have, that's always true. It often helps me to use an example. So let's say we're working for a email company and we've got to decide incoming emails, are they spam or are they not spam? We've got to decide which to send to the spam folder. And so what we do is we take a lot of past emails, we have users tag whether they were spam or not, and then we train a few machine learning models to predict for new emails, are those new emails spam or are they not spam? Now, let's say in our data set, we have far more not spam than we do spam. We might have, let's say 2% of the emails are spam. You might be wondering, why do we need AUC? Why don't we just use accuracy? So the issue with that is, what if we just sent every single email to the inbox? We said there's no spam at all. We would end up with 98% accuracy, which sounds like it's pretty good, but in reality, our model did nothing. Our model is just passing everything through. So we have a useless model that gets a really good accuracy. So clearly, accuracy is not the metric for every use case, and certainly not this one. So what AUC does is it actually it measures what directly comes out of the model. See, almost no machine learning models will directly predict spam or not spam. They'll predict a number that's between 0 and 1. And then after the fact, either the software you're using or you do it manually, but you take those and you round them to 0, you round them to 1, and assign spam or not spam. And you can round it based on what's above 0.5, or you can use any threshold you want. But to use accuracy, you have to do that step. But the model does not do that step. The model just gives you a number between 0 and 1. So with accuracy, you're not directly measuring the performance of the model, but with AUC, you are, because you're looking directly at those numbers that come out of the model, the numbers between 0 and 1. And so it has the advantage of directly measuring the model itself and not any tasks or steps that come after the model. And so to give it some more context in our spam problem, the AUC is going to measure how well we separate the two classes, how well we separate the actual spam from the not spam in terms of how high our predictions are between 0 and 1. So in the case I said earlier, let's say we sent nothing to spam, we sent everything to the inbox. It didn't separate anything, so that's no better than random. That's no better than 0.5. Let's say we had, everything we sent to the inbox was perfect, or let's say every non-spam was predicted lower than every spam, then that would be a perfect AUC. It's perfectly separating the two. And so that leads to maybe another way to interpret the AUC that might make more sense is it's the probability that the model ranks a spam higher than a non-spam. So that it's probability it ranks a spam higher than a non-spam. So you have that interpretation, you have it's between 0.5 and 1 always, regardless of the application. It's directly on what comes out of the model. And so I would argue that it's the only metric that you need to use.
Fantastic. Thanks, Robert, for the overview and the argument. Now, Aric, you've got give or take 5 minutes for rebuttal, or for your opening statement, rather.
Sounds good. Perfect. Thank you so much, Evan. And Robert, I love your talk about accuracy not being a good metric. I agree. Can we just turn this into bashing accuracy for the next 30 minutes? Because I think it's an absolutely horrible metric. But outside of that, let's go back to the original one. I love your example about emailing in the spam folder. And I think that actually helps a little bit sort of my argument against something like AUC. Reason being that for me, a lot of times, the way I think about a classification problem is not always getting both the ones and the zeros correctly. It's usually focusing on one of the classes. So something like an email spam folder where you have the ones and we're focusing on really, I need to identify where the spams are with trying to minimize as much non-spam as possible. And if a couple of those, non-spam sneak through, they sneak through. So I'd make an argument against something like AUC being the only metric, because AUC does a wonderful job of being able to try and figure out a notion of balancing sensitivity and specificity, focusing on the prediction of the ones and the zeros, when in reality, maybe we only care about predicting one of them really well. So something like lift or something like a gains chart, for example, will do a really good job of being able to say, this model is really good at identifying quickly who your spam emails are, and all the rest of them, whether they're ranked higher, ranked better, or lesser, more spam, maybe not so much, but we've identified the definite spams. And so that's where I would think something like a lift or a gain chart would be better. But also trying to be able to balance things out in terms of not just focusing on predicting ones and zeros from a true positive and a true negative rate. Again, Robert did a wonderful job explaining AUC. So let me quickly define true positive, true negative for the audience. True positive would be something along the lines of, if it really was a spam, how many times, what percentage of the time did I actually say it was spam? True negative would be something along the lines, if it really wasn't spam, how many times, what percentage of the time did I say it really wasn't spam? And so that would sort of be the idea that what AUC and where it comes from, the ROC curve, is trying to balance. However, something like precision, I think, would also be really good in this scenario, where we're trying to be able to balance that idea of all the things that I predict spam, how many of those did I get right? It's not just of all the actual spams, how many did I capture, but of all the predicted spams, how many did I get right? So again, another metric maybe we want to be able to balance in there outside of AUC. How good does your model do in terms of precision across different rankings, which actually ties directly to lift? And so precision across many different cutoffs, much like you described, when many different cutoffs can help us determine that balance overall for AUC, precision across many different cutoffs would be something like lift that, again, I think would go a long way to being able to help out. So I think there's my initial opening statements to be able to help out, keeping a couple just in my back pocket just in case.
Awesome. Thank you, Aric. Robert, a couple minutes for rebuttal.
Sure. Yeah, that was really good, Aric. I actually, part of me agrees with a lot of what you're saying. but here comes the other part of me, I guess.
It's good to see you're arguing with yourself. That's always good. It's always good. It's helpful.
Yeah, so I completely agree that I think we have to make a distinction between how we communicate the value of a model to the business and how we actually measure how good a model is, and then compare the different how different models compare against one another. Okay, so you brought up a lot of good points. I think most of it can be condensed to you. Generally, you can narrow down what you really care about to either one class or maybe one region of the data set. Maybe you only care about the high predictions if you're doing lift. And so what I would say is, yes, that while that is true in a lot of cases, I would say those metrics can be very noisy, especially with something like lift. If you're looking at lift at the top 1%, you've now thrown away 99% of your data set in terms of sample size when you're evaluating. And that a model that discriminates and separates the classes well overall will tend to do so in all regions of your predictions moving forward. There definitely are counterexamples to this, but what I like to say, there are counterexamples, but your data set isn't one of them. So they're pretty rare, I would say. And I don't think we should base our common practice around the edge cases. Our common practice should be around what generally tends to be the case. And if you have an AUC that's significantly higher in one model than the other, then I would rely on that model more, almost regardless of what the task is, unless it's an edge case that's just completely out there.
Sounds good. No, I agree. It's one of those things, like, as you were describing the idea of, like, we could come up with an example, like we could all probably draw one right now where it's like, well, but what about this? And you're exactly right. I love that notion of, in a real world scenario, though, does this happen? And so I think my rebuttal would be focusing in on exactly what you said when it comes to the communication of the model versus the model metrics that we use to determine the model. And so you're exactly right. I think there's a lot of times how we communicate models as data scientists may not be exactly how we judge models as data scientists. But I want to push back on that a little bit. If we're trying to be able to reach the business user where they are and trying to help them understand why we chose what we chose, being able to summarize our model in a good way that they understand is helpful. But being able to take the perspective of, well, what if I try and find the model that may save you the most money? Now, that model may not be the best at being able to predict all of my ones and zeros. It may not be the model with the highest AUC. Maybe it has a much higher error rate for false positives. But in the end, it costs me much fewer dollars, let's say, to being able to make a mistake one direction or the other. And so with that being the case, instead of focusing on what we would think of as a good model metric as a data scientist, my argument would be that the actual business user, how they judge a model, would actually be more important for us to be able to pick models on. I think of a marketing thing. I'm going to think of the spam sender instead of the spam receiver on your emails now. As a spam sender, I could imagine I would rather send out many more opportunities for people to click on my email, even though I know very few people will actually do it. With the premise being, well, in the end, it costs me fractions of a penny to send an email. And if I send too many, I send too many. But if I miss one person who's going to send me all their money as a bad guy, well, I want to make sure I capture that one person. And so from a cost perspective, I think that could be a better way of evaluating a model's performance in terms of money saved or money earned, as compared to something like AUC, which might say, hey, this model over here is better, but in the end, maybe it doesn't make me as much money. I can't believe it, Evan. You've made me argue for a bad guy in this scenario. I'm blaming you completely on this.
Happy to advocate for our fellow bad guys, although I'm not nearly as bad as a spam sender, please.
I'll say, you said fellow. I just making sure that that's recorded. That's there. It's recorded. No editing.
Relative. Awesome. Yeah, I don't know, Robert, do you care to respond to that, or we could open it up to questions?
Sure. I'm happy to give a quick response.
Sure. Go
If
ahead.
that's allowed. Yeah. Um, so I would say that I completely agree again with your notion of we have to do whatever saves the business the most money, whatever makes them the most money. To me, that's after you've chosen the model that does the best. You would then choose where to draw that threshold based on what makes the most money, if that makes sense. So I think, and it sounds like you're saying you would switch the order of that. You would kind of choose that threshold ahead of time and choose whatever model does best on that threshold, and then give that off. And then I would also say the other comment I had was that I would think it's incredibly rare to see a case where you have a significantly higher AUC for one model and a significantly higher, lift metric or metric where you weighted one higher false positives more than false negatives or something like that in another model. Like I would think that almost always in a real world data set, significantly higher AUC will be perfectly correlated with all of these other metrics. And in a less noisy sense, you're more likely to see a AUC distinguish itself versus these other metrics might be more noisy.
If I could, Robert, I'll jump in with moderator's prerogative to ask a question. I think most folks would generally agree if you see significant divergence in AUC, you'd see significant divergence in these other metrics that might be more business relevant. What if you see very, very similar AUCs? Then would it make sense to jump to another metric? Is it possible, or it's possible with anything, but is it more common or more likely in the real world to see maybe very similar indistinguishable AUCs, but one model does a better job at the top of the data set or on the positive cases?
Yeah, I mean, it's certainly possible. I'm generally talking from the more common cases. If you have AUCs where there's like a lot of overlap and you especially have plotted the uncertainty intervals for both, and there's a lot of overlap with those, I would tend to think that basically what Aric's arguing, if I understand correctly, most of the time would be choosing a specific point where you're narrowing in on one point in that ROC curve. And it's possible, but I would think more often than not, if the AUCs don't have separation, then neither will the point you're interested in. Yeah.
No, I agree. To go to Robert's point, I think you're exactly right. I think it's, when focusing on a single point in a cutoff threshold, that is a little bit separate. I would make an argument that you could have two separate models, much like what Evan said, where you have, let's say, an XGBoost model and something like a logistic regression. Let's say they have a similar AUC. And in the argument of a similar AUC, then it's okay. If these two models are similar in their predictive power, then are there other metrics that we could potentially use to be able to decipher between them a little bit better? Now, where it comes to potential, you're right. I agree. I think from a lift and a overall model metric, you probably see some similarities. But you might be able to have some model that might be able to be quicker to evaluate in terms of time and scoring, in terms of, try to think of an example. What if you had a model that was more interpretable? What if you had a model that would make more business sense? And in those ideas, again, now it's a notion of, if I have models that are comparable on this metric, which model would I choose from? I'd go off of that metric to be able to find another metric to be able to help out. And so, and it's always hard arguing that you can only use one thing, but I get that we all generally understand that idea. But yeah, that would be my argument. Again, going back to that cost, where cost isn't necessarily just the cost of a false positive or a false negative, but now could be a cost of actual business. Like, how do we understand the variables that come from this? How can I sell this idea to my boss? How can I quickly evaluate this model on a realistic scoring scenario? How well can I put it into production? all those costs that may come into play as well.
Yeah, I very much appreciate it, Aric. And I'll ask you a question. Feels a little bit devil's advocate
Love it.
question here. We're thinking about cost. We're thinking
Mhm.
about a data scientist, data analyst, somebody who's building a model. And what you're proposing is learning a lot of business context. What is important? How do we measure the false positives, the false negatives? And would, there's some cost imposed on a model builder with that. Wouldn't it be easier if we just said, build us the model with the best AUC, and then we reduce a lot of contextual knowledge that they have to have. We reduce a lot of startup cost, and we just say AUC is a metric. It's going to be really highly correlated, if not perfectly correlated, with these other metrics that are business important. So why can't the data scientist just build for AUC?
To devil's advocate, why do I need a data scientist at that point? I mean, seriously, if we're just going to throw something into a computer and let the computer pick the best number, then I don't need any context. It's just X1, X2, and X3. I better go ahead and just shut these doors now. I don't need to teach any more of you all. This would become much, much easier. But no, I think it's a fair point, Evan, that a lot of people do make, right? Is that there's an argument for trying to get out of the context of the problem to be able to see the data in a more purer way. My counter argument to that always is a notion that the best models are the models that are fully understood by what's going into them. And this was a debate that maybe Robert and I will have for another day. I know we could both argue both sides of, but it's like, for me, feature engineering is far more important than the model you select. If you can give me a good variable, I'll take a good variable 9 times out of 10, 10 times out of 10 over a better model. And it's because of the fact that the variables are what drive models. Models don't drive variables. And without context and understanding of the problem, at that point, why would I, trust just what the model says? X1's the best variable. And then you turn out and you reveal the curtain, and X1 is just something that doesn't make any intuitive business sense. And the boss just laughs you out of the office. She's like, what are you even doing in here? Like, why did I hire you again? So that would be my counter argument to the devil's advocate. My angels argument? I don't know how that would be called.
Aric, you're really speaking my language here. First, empathizing with bad guys, then talking about boss laughing you out of the office. Like this, you're living in my world. So I've asked a few questions. I want to open it up to either of you. Do you have a question for your counterpart here?
I could go first. I have a list, but I would not like to debate you on what you just said, Aric, because I 100% agree. I was actually going to bring that up before you even mentioned it, because to me, when we talk about using resources, data science time, and et cetera, would you rather if you're employing a data scientist, would you rather them spend their time making all of these metrics that correlate and using those and calculating what's the uncertainty at lift at 3%, how do I compare that? Or would you rather them spend more time on feature engineering?
Oh, no, I agree completely. Feature engineering, hands down, would be where I would spend all of my time. However, the downside, though, is the whole context of the problem, right? They can spend all their time spinning their wheels on the feature, and then at the very end, if they can't communicate to me what's going to save me the most money or why it's going to be the most important, then we still have to have some metric at the end. And so I agree. But then that would be my argument of, if I had to pick a metric, although I do love AUC, like it's my baby. I love it. It's good. I'd go with something else that may be more business contextual, because in the end of the day, although I spent all my time understanding this business, if I can't explain it to my boss in a way that they understand, then all that time spent just goes out the window.
Perfect. Before Robert goes down his list, Aric, do you have any questions for Robert?
Oh, man. Okay, I guess I wasn't prepared to ask questions. I didn't think this would be like that kind of formal debate. All right. So I guess for me, Robert, a question I would have would be, outside of just AUC, why would something not like the rock curve itself and just the overall idea of examining rock curves be better than trying to summarize a rock curve, which is a picture, into a single number?
Just easier to communicate, easier to understand, takes less time. I think it can be difficult to interpret a ROC curve. I've actually spent probably a lot of time trying to get to the point where I can look at a ROC curve and immediately tell, like, I mean, in the extreme example, you have one model that's, goes up the vertical axis and then comes across, or you have one that just goes kind of diagonally up and then rides the top axis. And it's, to get to the point where you immediately understand the difference between those, it has some value, but it takes so long, and it's so rarely seen where you have different models doing opposite things with the same features. It just seems maybe not worth the time and effort from my point of view.
All right. Perfect. Yeah. Why look at a picture when a single number? Well, even somebody like Evan might could understand it. Okay. We're in the interest of time, we're gonna close the Q&A, and let's take I think a couple minutes, maybe 2 or 3 minutes. Robert, starting with you to wrap up, state your case.
Sure. So, in summary, the AUC for me is the best single metric to use when evaluating a classification model. It summarizes how well a model can distinguish between the two classes that it's been trained on, that it's trying to distinguish between. And because it uses the entire data set to make that inference, I would argue that when it concludes that one model is better, that is the most trustworthy thing you could use, even if your business case focuses on one area over the other. In fact, we've started to do some research and haven't finished it yet, but the early returns on it is that sometimes if your business metric is something like lift at 1%, the AUC is sometimes more highly correlated with the true lift at 1% than lift at 1% is on your data set, at certain sample sizes and everything. So if I completely, and to go back to what you said most recently, Aric, in your response, there's a difference to me between communicating the value of a model and distinguishing between which models are better. And while AUC can be communicated well to anyone, it's a number between 0.5 and 1. Higher is better. It's pretty intuitive. I think that it's far better if, by the end you're communicating it in dollars saved, or, how much you're making off of this model. What's the return on your investment if you use this model? However, in terms of which model is actually better, I would argue that using AUC will ultimately give you an answer that's more correlated with the business metric than if you had just used the business metric, because that uncertainty can be so high in a lot of real world data sets. Again, not always the case. There are edge cases for sure, but in the common use case, I think you'd be better off saving your time for things like feature engineering and such.
Perfect. Thank you, Robert. Aric, a few minutes to summarize your position.
Sure. Sounds good. I think for me, the best summary of the position is that although I do think AUC is probably one of the best of a series of metrics, to consider it the only metric would not be a valuable way of being able to look at an entire picture. And so when looking at the notion of being able to explain the context of something to a variety of different stakeholders, yes, maybe for us, it could be something where we look at it as this model may be best in terms of this AUC, but being able to throw out those other metrics and not use them even from a business context as a data scientist would be not a good practice on our end to be able to understand who we're going to eventually talk to. And so trying to make sure that we understand the full business problem so that when we talk to the business user, it's not just here, let me just make this so you can understand it. It's here, I actually understand your problem. And with understanding your problem came a different context to how I would have potentially looked at this model. And so I chose the model that best accounted for a variety of things, not just one that accounted only for a single metric.
Perfect. Gentlemen, thank you so much. I've just gotten the results. They are finalized for the debate.
Wow, there must not have been a lot of viewers. That was really quick.
We've got an AUC. I don't think that's too important. I'll skip over that. Let's see what's the most important. Yeah. This has been the friendliest debate, I think possible. You guys have been great, very thoughtful. Really appreciate both of you coming on the show. We hope our listeners walk away from this being able to thoughtfully implement classification models and aware of the metrics that they're using. So really appreciate both of you guys for coming on the show today. Robert and Aric, thank you guys.
Thank you so much. It's a pleasure.
Thanks, Evan.